Hi, 7th graders, it's Mr. Welton. Hoping you are all doing well. Here's our next lesson on probability. Chance experiments with outcomes that are not equally likely. So in the previous lesson, you learned that when the outcomes in a sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. So down here is our total number of things that could happen. Up here is the one that we want to happen, or the success. So for example, if I'm talking about rolling a die and trying to get a specific number, let's say I want to get the 1, there is 1 out of the 6. Okay, so however, when the outcome in the sample space are not equally likely, we need to take a different approach. Here's our first example. When Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in this table below. So this first row here shows us how many bananas. Please notice that it goes from 0 to 5. And then the bottom row is the probability of that happening. And it's 0.1, 0.2, and 0.3 is our possibilities. The first question, what is the probability that Jenna will buy exactly 3 bananas? So that's just a matter of reading the table, finding the 3, and getting the answer is 0.2. Decimal is an absolutely fine answer, but if you'd like it to be a percent, don't forget that we could move it 2 places to the right. Here, take the decimal, move it 2 places over, fill in any zeros we might need. So that would be the same as a 20% chance that she is going to buy exactly 3 bananas. So let's go to our next one. Can you locate it before I get to it here? What is the probability that Jenna does not buy any bananas? So not buying any bananas would be 0. So that one on the table is 0.1. That is a fine answer, but if you'd like to see it as a percent, we can just move the decimal 2 places to the right. And that is a 10% chance that Jenna is going to not buy any bananas. C, what is the probability that Jenna buys more than 3 bananas? Okay, so if I want it to be more than 3 bananas, it would have to be this stuff above it. So that is the 4 and the 5. So I'm going to take both of those probabilities, 0.2 and 0.3, and I'm going to add them together. So that gives me 0.5. Again, if you'd like it a percent, we can move it 2 places over, and that is going to get me 50%. So there's a 50% or equally likely odds that she is going to buy more than 3 bananas. Our next one, D. D, what is the probability that Jenna buys at least 3 bananas? Now we're still kind of thinking the same thing, but if I say at least 3, it means now 3 is a possibility, and we're going to go up from there. Because like on your grade, you want at least a 65 to pass, but you would love something higher than that. So at least means I'm going to start at that number, the 3, and then I'm going to work my way up. So I'm going to add all those together. Here's my 0.2 for the 3, my 0.2 for the 4, and my 0.3 for the 5. I'm going to add those up and get 0.7. If I would like to make it a percent, I'm going to move it 2 places over. So that is a 70% chance that she is going to get at least 3 bananas. So that is highly likely. If you remember our vocabulary that we were using from that table. Okay, what is the probability that Jenna does not buy exactly 3 bananas? So we don't want 3 bananas. So that leaves everything else. So one option that we have here is just to add up everything else. So I've got 2 0.1s, 3 0.1s, a 0.2, a 0.3, and that is all going to add up to 0.8. If I'd like to make that a percent, I'll move it 2 places over. 80% chance that she's not going to get exactly 3. She'll get something else. It doesn't say if it's higher or lower. It's just something else. Okay, in case you didn't notice, those numbers all add up to a total of 1 if you were to add them all up, or 100%. but that should make sense if those are the only choices. So if she only buys between 0 and 5 bananas, that is all the possibilities, and that's going to make 100%. So on that last problem, we actually have a second way we can do it. If they're saying not 3, and we know that 3 was 20% chance, we could take our full 100 minus the 20, and everything else that is left would be all those other numbers that were left. So 100 minus 20 gets us 80%, which is the same answer as what we got. Here is our next problem. Jenna's husband, Rick, is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruit and vegetables. So the probabilities are given below. So since these are the only possibilities, as I was just mentioning, I know that this is going to work out to 1 if I was to add it all up, which is 100%. The first one says, on a given day, find the probability that Rick eats 2 servings of fruit and vegetables. Take a second and find 2 servings of fruit and vegetable. Okay, so if you said 0.28, and if you would like to change that into 28%, you are correct. Okay, our second one, more than 2 servings of fruit and vegetables. So find the ones that are more than 2 servings. So if I'm looking for more than 2 servings, that would be my 3 and my 4 over here. So I'm going to add 0.39 and I'm going to add 0.12. So that comes out to 0.51. And if I want to write it as a percent, moving it 2 places, that is 51% chance that he is going to eat more than 2 servings of fruit and vegetables. And lastly, at least 2 servings of fruit and vegetables. Consider at least. At least means I want to start with a 2 and work my way up from there. So that is going to be 0.28, it's going to be the 0.39, and it's going to be the 0.12. I'm going to add all those up, and that gets me 0.79, or 79%. Lastly, down at the bottom, find the probability that Rick does not eat exactly 2 servings of fruit and vegetables. Okay, so we don't want the 2, but we want everything else. So I could take the time and I could add those 4 up, or I could just take 1 and subtract the 0.28 and see how much is left. And that nice easier way gets me 72% or 0.72. Okay, so occasionally it'll be given in decimals. Hopefully most of the time it's given in decimals, but it could also be given in fractions. So Lewis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. We'd like to find the probability that Lewis receives 3 or 4 phone calls. So I'm going to have to add those. And so now we got to do just a little bit of adding fractions. I cannot add them if the bottoms are different. So I'm going to look for a common denominator, and I can see that it's going to be 9. This one I don't have to change. I can just multiply by 1 and keep it the same. But this would have to be 3 times 3 is 9. And whatever I do to the bottom of the fraction, I'm going to do to the top of the fraction. So 1 times 3 is 3. So now I've got 3/9 and 1/9. Adding them together gets me 4/9. In a question like this, please leave it as a fraction. You could absolutely divide it and get a decimal or the percent if you wanted to, but especially like with a 9 here, that is not going to work out nice. And 4 out of 9 chance is easy to understand. Find the probability that Lewis receives fewer than 2 phone calls. So I'm going to add these two, fewer than 2. Now that is easier because 1/6 and 1/6, they already have the same bottoms, so I can just say 1/6 and 1/6 makes 2/6. And we probably should reduce. So 2 divided by 2 is 1, 6 divided by 2 is 3. You've got a 1/3 chance that he is going to get 0 or 1 phone call. Find the probability that Lewis receives 2 or fewer. So I'm going to have to add all this together. Now those do not have a common denominator. I'm going to do it over here on the side. So I need something that 9s and 6s can turn into. So let's use 18. This would be times 2. So that is times 2. This is times 3. And the top one will also be times 3. So here are my 18ths. I'm going to add 3, 3, and 2. So that is 8 out of 18. If I reduce it, I would get 4/9 as the possibility. So you have the same, if you look at that first answer, you have the same probability of receiving 2 or fewer calls as 3 or 4 calls. Okay, lastly, what is the probability does not get 4? So if it's not 4, it's got to be all these other ones. So we could do this 100% again, taking the whole and subtracting 1/9. Well, that's not very easy until I change the 1 to a fraction. And what should I use as my bottom? How about 9ths? So a whole would be all 9 out of 9 minus that 1 out of 9 means that he has an 8 out of 9 chance of not receiving 4 phone calls.